Tell me about a time you fixed a difficult bug. Introduction. This is one of the most common behavioral interview questions for software developers. Interviewers ask this question to understand how you debug difficult issues, how you investigate root causes, how you handle unclear problems, how you use logs and monitoring, how you reproduce bugs, how you communicate with the team, how you prevent the same bug from happening again. This question is especially important for junior software developers, Java developers, backend developers, full stack developers, senior software developers, production support developers, team leads. The best way to answer this question is by using the STAR method. STAR means S, situation, explain the background. T, task, explain your responsibility. A, action, explain what you personally did. R, result, explain the final outcome. A good interview answer usually spends some time explaining how your experience and skills directly relate to the role you're applying for. It should mention specific accomplishments, relevant examples, and demonstrate how you can add value to the company. 10% situation, 10% task, 60% action, 20% result. The most important part is the action section, because interviewers want to understand how you approach the bug, not only that you fixed it. Question: tell me about a time you fixed a difficult bug. Example 1. Difficult null pointer bug in production situation. In one of our applications, users occasionally received an error while submitting a form. The issue was difficult because it did not happen for every user and was not easy to reproduce in the lower environment. Task: I was responsible for investigating the issue, identifying the root cause, and fixing the bug without affecting the existing form submission flow. Action: I started by reviewing the application logs and comparing successful and failed requests. I noticed that the error happened only when one optional field was missing from the request payload. The application expected that field to be present and tried to access a nested value without checking for null. To confirm the issue, I created test payloads with different combinations of missing and available fields. This helped me reproduce the bug locally. After identifying the root cause, I updated the validation logic to handle missing optional fields safely. I also added proper error handling, so the application would return a meaningful validation message instead of throwing an unexpected exception. I added test cases for complete request payload, complete missing optional field, complete nested object, complete nested object, complete nested object, valid form submission. Result: the form submission issue was fixed. Users no longer received unexpected errors. The new tests improved regression coverage and helped prevent similar null-related bugs in future changes. Why this answer works. This answer is strong because it shows log analysis, request payload comparison, reproduction of the issue, root cause identification, defensive coding, regression testing. Example 2. Bug caused by date and timezone logic situation. The business team reported that some records were appearing under the wrong business date in a report. The issue happened only for transactions created near midnight, so it was difficult to detect during normal testing. Task: I was responsible for finding the root cause and fixing the date calculation issue without changing valid historical data. Action: I started by comparing the report output with the source transaction records. I checked the API response, database values, report query, and date conversion logic. After investigation, I found that the backend was storing timestamps in UTC, but the report was grouping records using a different time zone conversion than the business expected. Transactions created near midnight were being counted under the wrong date. To fix the issue, I updated the date conversion logic to use the official business time zone consistently. I also added test cases for boundary scenarios such as check transactions near midnight, month-end dates, daylight saving time changes, UTC to local time zone conversion, report date filtering. I worked with QA and the business team to validate the corrected report totals. Result: the report started showing accurate data. The business team regained confidence in the report. The additional boundary test cases helped prevent future time zone-related bugs. Why this answer works. This answer is strong because it shows data investigation, check. Time zone debugging, check. SQL and API validation, check. Business impact awareness, edge case testing. Example 3. Difficult bug in Kafka message processing situation. In one of our event-driven applications, some customer updates were duplicated. The issue was difficult because it happened only during retry scenarios when the downstream service was slow or unavailable. Task. I was responsible for identifying why duplicate updates were happening and fixing the bug without losing valid messages. Action. I started by reviewing Kafka consumer logs, retry behavior, offset commits, and downstream API responses. I found that when the downstream API timed out, the consumer retried the same message. In some cases, the update had already been completed, but the response was not received before timeout. Because the message was retried, the same update was applied again. To fix the issue, I implemented idempotency in the message processing flow. Each Kafka message had a unique event ID. Before processing a message, the consumer checked whether that event ID had already been processed successfully. If the event was already completed, the consumer skipped duplicate processing safely. I also improved error handling by separating retriable and non-retriable failures. I added monitoring for duplicate event attempts, retry count, failed messages, processing status, dead letter queue messages. Result. Duplicate customer updates were eliminated. The Kafka consumer became more reliable during retry scenarios. The idempotency pattern was later reused in other event-driven services. Why this answer works. This answer is strong for backend interviews because it shows Kafka debugging, retry analysis, idempotency, distributed systems thinking, data consistency, long-term reusable solution. Example 4. Difficult bug after Spring security change situation. After a production release, some users were unable to access specific pages. The issue was confusing because login worked successfully, but certain users received access denied errors after logging in. Task. I was responsible for debugging the issue and restoring correct role-based access. Action. I started by reviewing application logs, authentication logs, and recent Spring security configuration changes. I compared successful users and failed users and noticed that the issue affected only users with a specific role. Then I reviewed the security rules and found that one endpoint required by that page was accidentally restricted after a configuration change. The frontend page was loading, but one backend API call was failing due to missing role permission. To fix the issue, I updated the authorization rule and verified the full role-based access flow. I tested. Check login flow. Check token generation. Check token validation. Access for normal users. Access for admin users. Unauthorized access scenarios. Affected page API calls. I also added automated tests for role-based access rules. Result. The access issue was resolved. Affected users were able to use the page again. The new automated tests reduced the risk of future Spring security configuration bugs. Why this answer works. This answer is good because it shows check security debugging, role-based access analysis, Spring security knowledge, production issue handling, regression prevention. Example 5. Bug caused by incorrect database join situation. A customer support team reported that some users were seeing incorrect account details on a screen. The issue did not affect all users, but it was serious because the screen displayed important account information. Task. I was responsible for investigating the data mismatch and fixing the bug safely. Action. I started by comparing the UI data with the backend API response. The API response already had incorrect data, so I focused on the backend service and database query. I reviewed the SQL query and found that one join condition was not specific enough. For users with multiple related records, the query sometimes returned a matching row that was valid technically but incorrect for the business scenario. To fix the issue, I updated the join condition to include the correct account status and effective date filters. I also reviewed similar queries in the same module to check whether the same pattern existed elsewhere. I added test cases for users with one account, users with multiple accounts, inactive accounts, future dated records, current active account selection. Result: the screen started showing correct account details.
The support team stopped receiving related complaints.
The review also helped us fix one similar query before it became a production issue. Why this answer works. This answer is strong because it shows click UI to API to database tracing, click SQL debugging, business rule understanding, careful validation, proactive code review. Example 6. Difficult bug in batch processing situation. A nightly batch job failed intermittently. The difficult part was that the same job passed on most days, but failed when a specific type of input record was present. Task: I was responsible for identifying the failing condition and fixing the batch job so it could process files reliably. Action:
I started by reviewing
batch logs, failed step details, input files, and database records. I compared successful files with failed files and found that the failed files had a few records with unexpected field formats. The batch job expected the field to always follow one format, but some records had an older legacy format. To fix the bug, I updated the parser to support both the current and legacy formats. I also added validation logic, so invalid records would be reported clearly, instead of causing the full job to fail. I improved the batch process by adding better record-level error messages, skip logic for invalid records, support for legacy format, restartability testing, sample test files for edge cases. Result: the batch job became stable. It processed both current and legacy input formats correctly. When invalid records appeared, the team received clear error details instead of a generic job failure. Why this answer works. This answer is strong because it shows CUC batch debugging, CUC input data analysis, CUC edge case handling, CUC legacy compatibility, CUC production reliability. Example 7. Difficult front-end and back-end integration bug situation. Users reported that a save button sometimes appeared to work, but the updated data was not shown after refreshing the page. The issue was difficult because there was no obvious error message on the screen. Task: as a full-stack developer, I was responsible for finding whether the issue was in the front-end, back-end, or database layer. Action: I started by reproducing the issue using browser developer tools. I checked the network tab and confirmed that the front-end was calling the save API. Then, I reviewed the API response and back-end logs. I found that the back-end was saving the data correctly, but the front-end was displaying stale data from local state after the save operation. The page was not refreshing the latest data from the back-end after a successful update. To fix the issue, I updated the front-end flow so that after a successful save, it either refreshed the latest data from the API or updated the local state correctly. I also added proper success and error handling messages. I tested successful save, failed save, page refresh after save, multiple field updates. Result: the save behavior became consistent. Users could see updated data immediately after saving. The number of support tickets related to stale data dropped. Why this answer works. This answer is good for full-stack roles because it shows check front-end debugging, check back-end verification, browser developer tools, API response analysis, state management, user experience improvement. Example 8. Difficult bug caused by concurrency situation. In one of our applications, users occasionally saw duplicate records created for the same request. The issue happened only when users clicked a button multiple times quickly, or when two requests were submitted at nearly the same time. Task: I was responsible for identifying the cause of the duplicate records and fixing the issue without blocking valid user actions. Action: I started by reviewing application logs and database records for duplicate cases. I noticed that duplicate records had almost identical timestamps, which suggested a concurrency issue. I reproduced the issue by sending multiple requests at the same time. The backend checked whether a record existed before inserting a new one, but two requests could pass the check at the same time and both insert records. To fix the issue, I added a database-level unique constraint for the business key. I also updated the service logic to handle duplicate insert attempts gracefully. Additionally, I improved the front end by disabling the submit button after the first click until the request completed. I tested X duplicate rapid clicks, X concurrent API requests, valid retry scenarios, database constraint violation handling, X user-friendly error response. Result: duplicate records were prevented. The system became safer under concurrent requests. The fix improved both backend data integrity and front-end user experience. Why this answer works? This answer is strong because it shows concurrency debugging, race condition analysis, database constraint usage, backend and front-end fix, data integrity improvement. Best short answer version. If you need a short interview answer, you can say, in one of my projects, users occasionally received an error while submitting a form. The issue was difficult because it did not happen for every user and was hard to reproduce. I was responsible for debugging the issue and fixing it without affecting the existing form flow. I started by reviewing application logs and comparing successful and failed requests. I noticed that the failure happened only when one optional field was missing from the payload. After reproducing it locally, I found that the code was trying to access a nested value without checking for null. I fixed the validation logic to handle missing optional fields safely and added proper error handling. I also added test cases for complete payloads, missing optional fields, and invalid values. As a result, the issue was resolved. Users no longer received unexpected errors, and the new tests helped prevent similar bugs in future releases. Common mistakes to avoid. 1. Saying only, I fixed a bug. Bad answer. Bad answer. I found the bug and fixed it. Better answer. Explain how you investigated, reproduced, identified the root cause, fixed it, and validated the solution. 2. Not explaining why it was difficult. Bad answer. There was a bug in the form. Better answer. The bug was difficult because it happened only for specific payloads and was not easy to reproduce. 3. No root cause. Bad answer.
The application was throwing an error.
Better answer. The root cause was missing null handling for an optional nested field. 4. No testing. Bad answer. I fixed the code and deployed it. Better answer. I added test cases for valid payloads, missing optional fields, and invalid values. 5. Blaming other people. Bad answer. The previous developer wrote bad code. Better answer. The existing logic did not handle one edge case, so I updated the validation and added regression tests. Best practices for answering this question. Check. Use the star method. Choose a real bug. Explain why the bug was difficult. Show how you investigated. Explain how you reproduced it. Identify the root cause clearly. Explain your fix. Mention testing and validation. Mention prevention steps. Keep the answer around 2 minutes. What interviewers are looking for. Interviewers want to see whether you can. Say, debug logically. Stay calm when the issue is unclear. Use logs and tools effectively. Reproduce difficult issues. Identify root cause. Write safe fixes. Add regression tests. Communicate clearly. Understand user impact. For senior roles, they also want to see CAP production thinking, ownership, prevention mindset, code quality improvement, mentoring or team-level learning. Strong words to use in your answer. You can use words like check, investigated, reproduced, isolated, compared, analyzed, identified, validated, fixed, tested, prevented, improved, monitored. Example: I investigated the logs, reproduced the issue with a specific payload, isolated the failing condition, fixed the validation logic, added regression tests, and monitored the application after deployment. Difficult bug types you can mention. Depending on your real experience, you can talk about null pointer exception, incorrect date conversion, timezone bug, Kafka duplicate processing, Spring security access issue, incorrect SQL join, batch job failure, frontend stale state, race condition, memory issue, API timeout, data mismatch, validation bug, concurrency issue. Final summary. Tell me about a time you fixed a difficult bug is a very important interview question for software developers. The best answer should include what the bug was, why it was difficult, your responsibility, how you investigated, how you reproduced it, the root cause, the fix, testing, result, prevention. Good examples include null pointer bug, timezone bug, Kafka duplicate message bug, Spring security access bug, incorrect database join, batch processing bug, front-end backend integration bug, concurrency bug. The strongest answers are specific, structured, action-focused, and result-oriented.